Welcome to the R programming part 5. So we are going to learn in this slide we are going to learn about for and while loops. As you must be familiar with the idea of for and while loops. There's nothing new about it. It's just that we will look at it from R's point of view, how to use it in R, what are the codes. So for loop is again like for, and then in the bracket you put those counter or variables, and then in the curly braces you put the various statements that you're going to use. So we'll look at the example here. So you see I've defined one variable which is numeric variable 1 2 3 1 2 and 3, and this is the code here for, and inside the bracket I put the counter, that is I in A. That means I takes each value in each iteration, so from A, and then it prints I, the value of I. So in the first iteration I will take the value of 1, and then it'll print 1, then 2, and then 3. We can see the result here. See 1 2 and 3. So it has run for 3 loops, 3 iterations basically. Similarly for while loop we have the same code, like in the bracket we put the condition, and curly braces we put the various statements. So let's look at an example here. So we have defined B, initiated B as 0. We initialize the variable here, condition, and then while B is less than 3, we keep incrementing B, the value of B by 1, and then keep printing B. So the value would remain the same. Now next, conditional statements. Again, it's the same, nothing new here. If and else statement you must be aware of. So you put the condition if it satisfies the if condition, then you whatever you want to execute different statements. If this condition is not satisfied, then else. So let's look at the example here. So we initialize a variable A with 11, and then we are using this if and else statement. So if A is less than 11, print I have not understood loops, else print I have understood loops. So let's see the result. So since A is equal to 11 and is not less than 11, so if condition is not satisfied, so we will so this code will print else statement, which is I have understood loops. One thing we need to understand in R is that indentation is not important in R. Everything has to be in the curly braces, whether for function or for if else statement. So now we look at the functions code. So again, function is, as you know that how to define a function. So you have function, in the bracket you put the different arguments, and then in curly braces all the statements, and then the output. So let's look at one example here. So I've defined a created a very simple function, square. So what this function does is it takes the value, like this is the argument, and then it does the square, so multiplies the value by itself, and then prints the output. Again, for printing output you don't need to use the function print, but you can use function print as well. So see, we've taken 3 examples here: square of 3, square of 10, square of 5, and let's look at the results. So see, the results are square of 3 is 9, square of 10 is 100, and square of 5 is 25. So it's very simple. Now let's look at the graphics in R. So plot is one function, which is scatter plot function to plot graphs, and then it has many arguments. So I would suggest, if you want to know the different arguments or more details about this function, in R, if you want to know anything about a function, what you do is you type question mark, and next to that you mention the function name without bracket. So it automatically opens the help page, and there you can look at the different options. So suppose a function is available in different packages, so it will display all the packages with their respective links. So you, depending on which function from which package you're using, you need to click on that particular link and it'll open the details. So we'll look at one simple example here. So I've defined a variable x which is 1 2 3 4 5, and then y, random value. and then we use the plot function. So x is the x value, y is the y value, and then main is basically the name of the plot. X lab is the name of the x axis, and y lab is the name of the y axis, and color is red here. So, and you can additionally you can add different points by using this function points. So this is the location or the coordinate of the x and y, and the color of that point is blue, and COL stands for color, and PCH stand for the shape of that point. It could be circle, square, cross, or dot, or anything. Similarly, plotted a second point, the coordinate is 2, x-axis is 2 and y-axis is 4, and the color is green, PCH. Let's see what happens. So this is the plot. You see the initially x and y are all the square ones. You see these are these values, and then the blue, that's why we have red here. So all the red is these, and then first point is color blue, so this is blue, and PCH is 4, so the shape is cross. For this one, second point, it's the color is green, which is here, and the shape is 6. PCH is 6, so shape is inverted, triangle. There we have more options for more graphics here. So like you have histogram, then again you can use this method to know more about histogram. Then bar plot for bar plot, and you can use the same method to know more about bar plot. Then pie for pie charts. So we'll look at one example here. So par basically a function which divides the plot window, the graph window in R, into different sections. So 2 by 2 means it will divide that graph section in R into 4 parts. So you can plot at a time 4 different graphs in that screen or window. So histogram, I've taken one example here. So it's like, one, there are different values I put in here because histogram is basically for numerical values, right? And then I have to create one variable for bar plot and uh, pie chart. So bar plot and pie chart are basically used for categorical variables. So it will show how, depending on the number of each character or each categorical value, it will plot accordingly. So what we need to do is, when we are using this variable within this bar plot, we need to convert this into a table, and then only this bar plot and pie chart will work. So you can use the function table, and it will automatically convert this into a table. So let's see what we get here. So see, this is for the histogram example, this is for the bar plot example, and this is for the pie chart. You see green is 1, blue is 1, but red is 2. So red gets 50%, green 25%, blue 25%, and same here also. If you see this is red is double the height of blue and green. So this is how it works. It's very simple. Another thing that you need to remember is that there are many other options of plotting in R, and there are many packages like ggplot2, and there are many. These are all base functions available in the core R. But you want more advanced level of graphics, or for like say for 3D plotting, or for advanced level of plotting even in 2D, there are many options and many packages that you need to research online and find out. Here we have just provided the. So now let's look at how to save graphs into different files. So these graphs or plots can be saved as .pdf or PAS, BMP, PNG, JPEG format. And the way we save in R is that we open devices. What it means is, like for PDF, we use this PDF function, and inside the bracket we mention the name by which we want to save that particular plot. So what you need to do is, once you open this, type this, then the next line you need to type all the codes for the plotting, and then you need to close off this device by typing graphics.off, and it will automatically save this plot uh, as this by this name in working directory. If you want to provide a path, you can provide a path to save in different directory. Same goes with a PostScript, the same method we follow. And then if you want to similarly, if you want to like save as .bmp or .png, you can use bmp function or png function. And to close the device, you can either use this graphics.off or dev.off. Both work fine in this example and in this case. So thank you so much for spending your precious time. I hope this was helpful, and if you like this video, please like, share and subscribe.